by the way. I'll send you 10% of whatever I make off of it. A glow gun. I'm actually going to start the live stream so we can put this on our notes. That's a really great question. Making lumigons are really, really easy. So let's take a look at it real fast. Okay, so glowgons. And, hey, Grant, would you mind doing me a favor? Just hit a couple of the lights since you're over there, please. All right, so let's not use this crazy mesh because it's a lot of stuff in here. I'll just make a new project file, and I'll just put in a simple teapot. Okay, now I'm using the teapot because I want to be able to change maybe just the spout into a lumigon or a glowgon, as I'm going to call it from here on out. Okay. Now the whole idea behind a lumigon is that we use the geometry to start emitting light rays out into the scene. And there's actually two ways that we can do this. Okay. We can create a new material that will make the polygons associated with that material luminous, so they'll start emitting light rays out into our scene. Or we can create a new light type, which is called a mesh light, which does something very similar. And there are some benefits of working with mesh lights. The render engine is a little bit more optimized to use mesh lights, but it's also a little bit more difficult to control as well. So let me show you both, and I'll let you figure out how you want to apply it to your scene. First and foremost, to make a lumigon, we have to have a material assigned to the polygons that we want to have glow. So I'm going to have the spout of my teapot glow. I'll hit the M key to create a new material. And let's just call this lumigons. There we go. No. Glowgon. There we go. Plural, because there's more than one. All right. Voila. Now, the rest of our work happens inside of the shader tree. To make it a little bit easier for you guys to see what's going to happen, I'm going to jump over into my render layout. And, oh, this is fun. My preview window's gone. All right. Let me just restore some layouts here real fast. There we go. There's my good old teapot. And now we can start adjusting the material characteristics of our glowgon material. So here we go. It all happens on the material inside the group. So I select the material, and specifically there's one thing that we need to change. Now for most of our material work, we hang out in this material reference tab. But if we go into the material trans tab, this is where we can find the luminosity slider way down here at the bottom. The default value is 0, off. However, let's just put it to like 3.0 and make it a lovely shade bright red so we can see what's going on. And now our little teapot spout is glowing. Okay, pretty cool, huh? If our scene was entirely black, it'd be really, really apparent. Let's just do it real fast. That way we can see what it looks like in person. I'm going to go into my environment, and let's do this. Here's a fast way of just turning all this off. Yeah, there we go. So I just turned my environment material off. That gray gradient went away in the background. And we can really start to see that those polygons are actually illuminating the rest of the scene. This is a difficult system to work with because we don't get like bloom, okay? A lot of folks want to see that lovely kind of glowy effect. You're never really going to get that, and you're never really going to be able to control it all that well here in Modo. We can do a full-blown render, and there is a bloom post-processing effect that we can apply. So I just rendered this thing. If you go over into the image processing tab, there is a bloom section in here, and I rarely do it inside of Modo. Where is it? I may have. Vignette amount. Yep, there it is. Sorry. Thank you. So it's under bloom. I was looking for a bloom threshold, and we get a little bit. I mean, it's getting better, right? But in order for us to get this to really work, we have to super drive the values. So I actually did a full-blown render, and I'm in the image processing tab. You have to actually render it. Yeah, to get the bloomy effect. It's always going to glow when the material's on. But to adjust the bloom, it's a post effect, a post-processing effect. I guess what I'm trying to say here is that there are other ways and other applications that will do this better and faster. After Effects will allow us to do that.
And which tab? Where did you go into to make it glow? I was still looking with my old person site trying
That's
to
okay.
find.
So let's close your render window just for 1 second.
Close, close, or?
Yep, close, close. You don't need any more. So here's the material for the flame, right?
Mm-hmm.
If we go into the material trans tab, yeah, increase that value.
What did you put yours
I put mine at 3.
3?
Yeah.
But then I can't see it until I render it?
Well, you'll be able to see it in here. We may need to make it a little bit, yeah, there it is. It's glowing. We may need to make it significantly brighter. So, and you can also change the color of it too.
Can I apply this to it?
What is that? No. Yeah, those are, yeah, that would be fun.
But I
Yeah,
can't?
but you can't, unfortunately. Those are matte caps. Yeah.
Okay.
Yeah. You can change the color. Yep. Like I said, and there are other ways to start to modulate this effect. This is a channel inside of our render item, the luminosity. If you want to look into it a little bit more directly, you can have an image map inside of this and change the effect to luminous color. So if you wanted to have it be like orange or red down at the bottom, and then orange in the middle, and then white at the top, you'd have to create an image that defines those colors, and then you can change the effect of that image to define the color of the luminous rays coming out of the polygons.
Also, I noticed that when I updated my photo at home, I don't have all of these options. Like there is nothing in my materials and assets.
So the presets, yeah, there is a download. I don't remember the link off the top of my head, but it's on the Foundry's website. You can download the installers for all the presets.
That used to be on there, but when me and Luke looked, we couldn't find it. Was
Come talk to me after class. All right. So, oh, one more thing, just to kind of finish the question. Mesh lights are the other way of doing the exact same thing. With a mesh light, it's an item-based light type, right? So everything on that item is now going to turn into a luminous polygon. I'm going to get rid of my GlowGons material. Let's just delete this thing. Bye-bye. My spout goes away. And now, check it out. Under our lights, we have the good old mesh light, okay? Now, it requires an input. There it goes, down here. And it went away, and I don't know why it went away. Does it only happen at render? No. I have botched it somehow. I'll be honest with you, I don't ever use mesh lights. But I know it's in there. If you start looking at the documentation, you can check it out. I remember seeing when this came out, the last version or the version before, they were commenting pretty directly that there's the render engine is optimized to work with this light type. Oh, it may not be working because there's nothing for it to illuminate against. Let's do this. Now that we actually have something to illuminate, let's see if it works. Yeah, there it works. Oh, wait, is that the directional light? Yeah, nope, it's working. It's working. So the illumination of my little cube here is coming directly from the teapot. Okay. Now the power behind this, and the reason why you'd want to use this in reference to lumigons, is we can control it. We can now animate that item. If you want your light to move, you can't do that with a traditional lumigon, or it's a little bit more difficult to do with a traditional lumigon. So we can animate it, and I know that the render engine is optimized to work with mesh lights, I think, a little bit more efficiently than lumigons. So 6 to 1, half a dozen to another. Let you figure out how you want to use it. Yeah. You got the yellow screen too. Kevin got the yellow screen. Did you figure out what caused your yellow screen of death?
My mouth mesh when I basically try and do the subtract is when it goes sideways. So something weird.
Okay. For both of you guys, I have no idea what's causing it, right? But we got to start reverse engineering the conditions which causes the crash, right? Which causes the yellow screen. It sounds like Kevin's kind of zeroing in on the idea that it could be his mouth. Okay. What I would recommend that you look at.
But actually, just because I have like this pumpkin and I had two of the matches, inside and out. And actually, the inside one I created from the outside,
Yep.
And when I started working only with the inner
Yep.
mesh,
Uh-huh. Okay, this actually kind of goes back to the order of operations conversation that we were having, I think, before you came in. And let me kind of revisit this, because this is actually a cool idea, okay? Now, I can't do it exclusively with all these parts and pieces on my teapot, because it's not all contiguous. I'm just going to delete the handle and the spout. Let's get rid of those. So we're just left with this, and this will work. So we'll pretend that this is going to be our little teapot pumpkin, okay? Yeah.
Well, I was thinking like maybe like a, I don't know what to call it, it's that little pot that carries the sugar or the tea.
Yeah.
I don't know what to call it. Like it's a regular pot.
Yeah, why not? So we're going to have the outside. I'm going to duplicate this thing. And the second one naturally is going to be the inside, okay? And I'm going to go back to my Fusion tools just for 1 second under my cubic geometry presets, and this is going to be my mouth, okay? It's way too big. That's okay. We'll just pretend for today, because we're allowed to pretend because it's an art class, right? There we go. That looks not too dissimilar from the pumpkin mouth I made last week. So, okay. So we have to, the order of operations for Mesh Fusion is going to determine the outcome of the actual workflow itself. Okay. What we need to ensure that we do, in order to get something that works, is follow a pattern that looks not too dissimilar from this. And this is the way it was explained to me, and it worked really well for my brain. That we're really honestly, Mesh Fusion treats the base object kind of like a block of aluminum, a block of wood. And we're now carving things out of that block of aluminum, right? Like a big router bit, if you will, okay? We can't carve out the inside without the hole for the mouth first, right? Because then it has nothing to create the thickness from. We can't hollow out the core of the pumpkin until we have the boundaries of the pumpkin established, the mouth shapes and the eye shapes and all that jazz, okay? So here's what I'm going to do. I'm going to go back to my inside mesh object, and under the deform category, we have a great tool called push. I love push, okay? Because push is just going to move the verts along their normal, something like that. Now, it went to garbage pretty quickly at the top, but that's okay. Let me unsubdivide it. Usually when this happens, it's the mesh telling you what it will and will not do. So I'm just going to delete the stuff that I don't need. There we go. And run fill quads on this top loop. There we go. So now it's a subdivision surface, and we can incorporate it inside of our network. Okay. All right, so now let's start making the network, the Fusion item itself. I got my Teapot outside selected. I'll create a new Fusion item from it. Okay, so we're up and running now. And now I'm going to subtract the mouth from the outside first. Okay. Subtract it. Bloop. There it is. It's working. However, if I was to turn off the Teapot inside mesh object, yeah, it's just a gigantic void in there. It doesn't really create the illusion of a carved out, hollowed out pumpkin. So let's do that now. So the third and final step is getting the inside subtracted from the outside. Okay? Because now when we subtract it, it all works. Ta-da! There it is. Okay? So we have to cut the mouth shape first before Fusion understands how to hollow out the rest of it. Okay? So we can't core out the inside until we've defined, a thickness between the inside and the outside. There has to be something that connects. There has to be some sort of geometry that connects the outside to the inside in order for this to work. Okay, yep, good, good. Now do one of your outsides, like go grab your right eye. Okay. Oh, you're hitting the wrong one. Go back in time. You want to do the second one, that one. Okay. We also may have some display properties going on. It's frozen, okay. Okay, we can take a look at it during lab today and we can get it working. It's no problem. We'll figure it out. we got to move on because we got some new stuff today that we need to accomplish. Okay. All right, so this week, dun, 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 what we're going to talk about, like just all zoomed in. This is crazy. There we go. Let's get back to 100%. All right, so if you go into the Week 11 module, and I can't believe that it's already Week 11. How about this? Maybe I should make it live. The left hand does not know what the right hand is doing today. There you go. If everyone refreshes their page, everything's up and running. Yeah, go ahead and refresh your page. Yeah. Refresh. Everything should be up now. I'll refresh as well. There's your blows. There it is. So we're doing two things this week. We're going to start talking about dynamics, okay? And I think you're really going to like this conversation. So we have two accomplishments or two missions that we're striving to accomplish this week. Our first is going to be a simple, kind of a fun little lab assignment where we're going to play around with replicators. You're going to find that replicators inside the Moto workflow is a really important part of our duplication system. And it's going to allow us very directly to make a tremendous amount of detail very, very quickly. Okay? In addition, we're going to start talking directly about rigid body dynamics, and we're going to do a fun little domino rally. And if you don't know what a domino rally is, I've supplied you with an excellent video source of inspiration here. So this is a domino rally. So you're going to be creating a whole series of dominoes.
Well, we kind of knew what a domino rally is.
Well, now everyone knows, right? And you're going to be doing something like this, right? It's going to be a 10-second animation that really employs active rigid bodies into our animation system, okay? So, cool, huh? Should be pretty fun. Should be a lot of fun. I'm looking forward to seeing what you guys come up with and create. It's going to provide you guys with some great opportunities to flex your creativity. But let's start off today by talking about replicators, because it's going to be part of our lab assignment. You're going to be building a city for your lab this week, okay? And I think you're really going to like it. I know some people are like, what? We're going to build a city? Don't worry, it's going to be a whole lot better, okay? I think once you start to see the details of how the replicator engine works, you're going to see the awesomeness of it. So there's really a couple of things that you're going to be asked to build. You're going to be generating a city that includes a whole lot of buildings. You're also going to be using replicators to make light posts inside the scene. And we're also going to be placing cars inside of our city as well. Okay? Now don't freak out. Everyone's like, oh my gosh, you want me to build a city? I'm going to build a city in 10 minutes today. Okay? Yeah. An entire city is going to grow in front of us. And I think you're going to find that replicators are going to change your way of approaching duplication, okay? Because duplication in Moto, or in any app for that matter, is kind of one of our bread and butter things. That's what the computer excels at doing. It's copying and pasting things and having a tremendous amount of data for it to manage, okay? When you look at these big budget VFX films, they're not making just one model anymore. They're modeling entire cities, okay? How can we do that efficiently at scale and in a way that can render and that we can control and animate? It's a good question, right? Do you think they're really going in and modeling every single window and every single door? Yeah, no one's going to do that. No one wants to do that, right? That's a tremendous amount of work. I know for the first Avenger films, and this isn't anything new, they've done it actually a couple times. For Avengers 1, ILM made a scale model of New York City. Yeah. Do you think they honestly went in and they modeled every single window and door? No. That's impossible. They would still be working on the model today if they were going in and modeling every single window and door, every lamp post, every slab of concrete on the sidewalks. They would still be working on it today if that was the goal, right? So there has to be a better system of duplicating large data sets, okay? And replicators are Moto's implementation of that idea, and I think you're really going to dig it, okay? Replicators have changed my workflow, okay? Yeah.
So for this project, like, do we have to move the cars or?
No, it's just going to be a static model. I think you're going to just animate the camera going down one of the city streets, okay?
Oh, kind of like Spider-Man?
Like Spider-Man, yep.
Or Evil Dead, well, you know.
Yeah. So let's get into it. Let's check it out. It's a whole lot of fun. Let me start off with the new project file here. All right. So replicators are a pretty neat system, and we're lucky to have this type of technology because now we really can have geometry for like every single tree in our world, right? It's no longer a fake anymore. In the good old classic days of computer graphics, they would just have two-dimensional planes that were textured mapped with pictures of trees on them way in the background, and they were so far away from camera and the resolution was so low that you wouldn't even really see the effect. Well, now we're at a point where we can actually put three-dimensional geometry in the shots themselves, and every tree is a piece of geo, which is pretty neat, okay? But we have some big-time concerns and some problems with that, especially when we compare the outcome to kind of a more traditional duplication system. Let me just kind of illustrate this idea for you really fast, okay? And I'm going to go into my mesh preset library here real fast, and let's just duplicate, I don't know, this rubber chicken. Why not? We're going to start the day with a fun rubber chicken, okay? Now, if we were to simply just render this guy, let me compose the shot here. There we go. Okay, so let me just render this out. And I'm doing this just to kind of create a baseline comparison of both the geometry cache and how long it takes Moto to render this one little rubber chicken, okay, or a cartoon chicken. Okay, so let's look at our stats. So it took 8.2 seconds. Awesome. It used, let's see, down here at the bottom, it rendered out, 33,000 polygons. Okay, and then specifically, check it out, the geometry cache is at 3.71 megabytes. Okay, that's how much information the RAM is holding on to in order to draw all the polygons in this frame. This is something as artists we need to be very mindful of because we only have a limited number of resources on these machines, right? I know at this scale, at the scale that we're on now, it seems infinite. But when we start duplicating millions of trees, this is a limitation that we need to be aware of. Okay, so the geometry cache actually has some value going forward. Okay. Okay. So that's just one chicken. If we were to do a straight up just item level duplication of this, Control D to make a copy. Now I got two. Okay. Let's make this a little bit more engaging. I'm going to use the clone tool. There we go. And let's put a couple of them in there. Let's render it again. See what we get. Now on the surface we should have 5 times as many polygons, and it should take 5 times as longer, right? So let's see what we actually get. Polygonally, yeah, we got about 5,000 or 5 times as many polygons, okay? Ish, okay? And it's taking, it's probably going to take right around 30 to 35 seconds to finish this thing. There we go, 32.1 seconds. So about 4 times as long to render. That's kind of on par with what we should expect, okay? Now, if we're doing millions of trees, this is a problem for us. Or if we're trying to do the entire city of New York, this is a problem for us. We've only increased the polygonal count of our scene marginally. 166,000 polygons is not actually all that much in the grand scheme of things. It's not a lot of geometry. I just finished working on a sculpt of a dinosaur that I think at the end of the day had 42 million polygons on it. Okay. Yeah, I mean, we're lucky that our computers and our system now can accommodate millions of polygons. Geometry on a single asset level is now becoming something that we don't have to spend a tremendous amount of time thinking about, which is great. This is the brass ring that we've all been trying to grab. We want to get to this point. But when it comes time to rendering things, we have to be mindful of how this is going to impact the performance of our rendering engine. Okay? So this is with straight up item duplicates. Let's do the exact same thing, and I'm going to get rid of all my chickens. But now I'm going to do it with instances. Okay? Same thing. Hold down the Option key to do an instance clone. Same thing. Okay? Let's render it again. see how we do. Now, what's the difference between an instance and an item of it? So in an instance, it's referencing back to the original to find all of its geometric information. We can't change the polygonal shape of an instant. We can animate an instance. We can change its basic transformation, move, rotation, and scale. But we can never change the polygons, right? This gives us a tremendous render increase because now the computer is not having to manage 5 separate items. It's having to manage the geometry of one item and then just understand that that one item's geometry is placed at 5 different locations inside the scene itself. Yeah, so to make an instance, so you got to click on the original, right? And over in our duplication tools, holding down the Option key, instance clone. Okay. Now the big benefit of this is that I can change the original. For example, maybe I want to have his beak be a slightly different shape. I can change the original. And you can see that all of the instances update automatically as well. Okay. That's the big benefit of it. I use instances all the time. Okay. Especially if we know that we need to have one thing, duplicated a million times, and they all need to look exactly the same. Okay. Now, when it comes to our, so when it comes to working over here, our render time is pretty much the same. Okay. Our geometry cache, let's keep going down, pretty much the same. Actually, I think it may be even a little bit higher than it was before. Okay, because it's still having to manage all these polygons, but it's not having to manage the shape of all these polygons, right? So there's not a tremendous amount of render bonus, if you will, when working with instances. It's more of a workflow bonus, right? We change one, and all the copies that are duplicated, or excuse me, all the ones that are instanced from the original get updated as well. That's pretty cool. Okay.
So it won't affect the render time?
It's still going to be about the same. It's not going to be like this huge increase where it goes down to next to nothing, right? Yeah. So there's a third option in here that we should look at, and they're called replicators. Now, the big drawback for replicators is that we can't change the shape. Okay, it's not like an instance where we change the master and all the copies underneath it automatically update. Okay, what the replicator system allows us to do is to basically just transfer or just duplicate the geometry. Okay, it's not having to manage the item level information, so it's not creating transform channels, animation channels like it does for all the instances, right? Because when you render, or excuse me, when you duplicate an item, you're actually duplicating all of that animation data as well, or the ability to animate. All the transform channels are being duplicated. These are separate, discrete little pieces inside the scene. With replicators, all it's doing is duplicating the geometry. It's not allowing us to, to animate any of these instances, okay? Which makes it a great system for us to create high-resolution, high-detailed environments without the cost of having a zillion items inside of our item list, and which is going to bring down the performance of our render quite directly, okay? And it allows us to control things a little bit differently, too. Let me show you what I'm talking about, okay? So let's go ahead and start making a replicator, and you're going to be doing this for your lab assignment this week, okay? Replicators are pretty fun. I think you're going to dig it, okay? But there are a couple things that our replicator needs in order for us to duplicate my chicken a million times, okay? And I'm going to duplicate this chicken a million times here. It's going to be awesome, okay? We're going to start off pretty slowly, and then we'll go on to do something more complex. So there's two things that our replicators need, okay? It needs to have what's called a prototype, which is basically the raw mesh itself, okay? It's the thing that we want to copy a zillion times. And then we need to generate what's called a point cloud, okay? We need verts inside the scene, okay? Now, the point cloud data can come from just about any item that contains vertices on it, right? It can even come from a simple little square. Let's just do that real fast. I'm going to go back to my basic modeling tools. Come on. I'm going to hold down the Shift key, and I'm going to add in a square, okay? Now, of course, at this square, there are verts at the corners of each one of these faces, right? Wherever there's a piece of geometry, so right now I got 8 of them, wherever there's a vert on the point cloud, a chicken's going to appear. So the location of the verts is going to determine the location of the duplicate chicken, okay? Let's just do it real fast. And just so everyone's on the same page, I'm going to rename this item point cloud. Okay. Now, in order for us to create a replicator, it's its own separate item. You can find that item down in the particles section, replicators. Okay. So we're going to create a replicator, and then we got to do some simple wiring up. Okay. See how it's grayed out? It doesn't have the correct inputs in order for it to generate all the duplicates. Okay. Let's do it real fast. It's really, really easy. I don't care about the transform information, but I do care about the prototype. The prototype we know to be what? The chicken. Okay. And the point source or the point cloud is going to be the cube. Okay. Ta-da! Okay. Now, where each one of those little bounding boxes are is going to be a chicken. And at the moment, the computer is choosing to display all of our replicated items as simple little bounding boxes. Okay. However, the moment we go over into our render environment, and I'm going to hit the F8 key to bring up my preview render. There we go. Now I have 8 chickens. Okay. That's pretty cool, right? Yeah. Awesome. So let's render this now. Okay. And I'm going to turn off the visibility of our cube. You actually don't have to have the point cloud visible inside of the scene for this entire system to work. So we can turn the visibility of that off. And now I have 9 floating chickens. Okay, 9 of them now. Let's render it. I rendered 9 chickens in 9.5 seconds. Just slightly slower than it took me to render 1 chicken. Okay, that's pretty cool. And I'm rendering 9 of them. If you look over at the geometry cache and the number of polygons that you're rendering, it's still managing more polygons than what we had before. Because with 5 chickens, I think we had 166,000. Now with 9 chickens, we have 303,000. So we are actually rendering all this geometry. But because it's not having to manage all the transform channels, all the item level information, if you will, it's rendering wicked fast. Okay, wicked fast. The only way to change the location of the chickens is to change the location of the point cloud. Okay, not the mesh. Yeah, so that's the one drawback, is that this system is perfect for items that you don't want to have the geometry change, like a building, lampposts, cars, trees.
What about animating them?
Animating them? Yeah, so if you want to animate them, you have to animate the point cloud. I'll show you that here in a second. Hang tight. Okay. So we can make them move, but we're going to have to make them move a little bit differently, and we'll talk about this here in a second. All right. So let's amplify this a little bit more, because on the surface this is pretty cool duplication technology, but we really can push this a little bit further to highlight the power of replicators. Okay. Now for me, I think what I'm going to do, just because it's funny and it's weird, I'm going to get rid of my cube. Bye-bye. And this time I want a donut. Okay. There it is. So at each one of these verts, we're going to have a chicken. It's a lot of chickens. Okay. Let's do it real fast. Now I want to make the donut a little bit bigger. That way these chickens are not penetrating into each other. It's going to be a gigantic ring of death here. Ring of chickens. Okay. If we go back to our replicator, all we really need to do is change the point source to the donut. And now I got chickens everywhere, which is a tremendous amount of fun. There they all are. Okay. If we open up preview, there they all are. Now I have a lot of chickens. A lot of chickens. If we turn the visibility of my donut back on, you can see that the chickens are all kind of standing up, which is kind of fun. So imagine this is like a forest, okay? Some trees are going to be bigger than other trees. We don't want this one tree model to all be facing the exact same way, so we want to vary the outcome of this a little bit, which really allows the properties of the replicator to shine a little bit. Check it out. I got my replicator selected over in my item list, and if we cruise down to the bottom here, we have a whole series of variation properties that will allow us to change how the replicator is duplicating all this geometry. What if we want to have some random twist in here? So like a 45-degree twist. There we go. Now it's updating. Takes a second on these little iMacs. Yeah, now some are facing some way, some are facing others. It's just random. They're all facing different directions. And we can even increase the illusion a little bit more. Yeah, check out this. This one's facing, his beak's facing down. His neighbor, his beak's facing to the right there. Shoot, we can even do some random scaling. This is kind of fun. So let's maybe do, I don't know, 50% random scale on X, Y, and Z. Now we got some big chickens and we got some little chickens. Okay? Which is pretty fun. The offset is going to physically move the chickens away from the verts on the point cloud itself. So if we wanted like some to be floating above or some to be pushed down below the surface, we could do that. So let's do, oh, I don't know, let's do 1 foot, see what we get. Yep. This guy over here is floating. This one's pushed down, so now we can start to vary the height of all of this, which is pretty cool. Pretty cool. Yeah?
Is it basically just 90 degrees or not 90 degrees, or is it any kind of variation in between 0 and 90?
I think it's 90 degrees or 90 degrees, so it's going to be increments of 90. Because if you look closely, yeah, they all seem to be pointing at 90-degree increments. So if you wanted to be a little bit more of a finer angle change, maybe put this down to like 10, 10 degrees. And now, yeah, it's a little bit more subtle, but they are rotated at slightly different directions. Let's put it back to 90 so it's really easy to see. That's pretty fun. Okay, let's try rendering this again. I honestly don't know how. Let's find out how many of these things I have. I really don't know. So I should have 288 chickens. Let's render this bad boy. See what we get. 288 chickens. Here we go. How long did it take to render one?
9.5 seconds.
Yeah, 9.5 seconds. Let's see how long it takes to render 288. Dun, 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 dun. Let's see. I'm getting impatient as I wait.
Yeah, if I had known this, I would have actually turned in that animation, but my computer kept crashing at 18 hours. Yeah, I had a lot of trees.
A lot of trees. Yeah, and this is how they do trees. It really is. This is how they do trees and high volume duplication. And this system, we can get really intense with this system. And if you're creative, you can do some pretty cool things. So it now took 48 seconds to render 288 rubber chickens, which is pretty amazing. Okay, yeah, I'm digging it. I'm digging it. That's pretty neat. You would not want to be able to do this at all with a traditional duplication system, doing item level duplicates or even instances. Okay, it gives us a tremendous amount of flexibility. Okay. So how are we going to work with this in the production of our little city scene? Yeah, go ahead.
Before you move on,
Yeah.
what's the random offset? What does that do?
Position. Yeah, just think of it like position, rotation, and scale. That's what it's doing. So down here, yeah, so this is the position. So if you look at mine, some of the chickens were away from the surface, and some of them were pushed under the surface. That's because I changed their random offset to a foot. Yeah, so this is just position, rotation, and scale. Okay. So you can find the replicator under the particles section of the item list. So add item, particles, replicators. And it's pretty neat. Yeah?
I'm trying to find like the building models.
Yeah, so if you look in the mesh preset library, the building models are in there. I think there's a whole category called skyscrapers. And that dovetails quite wonderfully into what we're going to be building for our lab assignment this week. Okay? So if we think about it, we have to have a system that allows us to control the placement of each one of these verts. Of course, we could do it pretty quickly using basic shapes. That's a good starting point. But what if we wanted to go in and make it a little bit more custom? What if we wanted to go in and place little verts exactly where we want them to be placed? Okay? Let's check out this. This is actually kind of a neat system. I'm going to keep my replicator. Okay? Keep my replicator. However, I'm going to delete my donut. Okay? Bloop. Okay. And for this example, let's do this. Let's start combining some technology that we worked on last week. Okay, I'm going to create a plane. And let me just subdivide this plane a couple times. So now I'm going to have a whole bunch of geometry on this. You'll see the method to the madness here in a second. Okay. Excuse me for a second. There we go. So there's my plane. Now, let's jump into our sculpting tools. There we go. This is my mountain retreat. The hills are alive with the sound of rubber chickens. Okay. All right, so there's my environment. Now, I want to be able to place rubber chickens inside of this environment, but very, very carefully. I want to be able to choose like where my skyscrapers are going to go, right? So check this out. There's actually some really great technology that we can leverage inside the duplication collection of tools, okay? Now, in other classes, we've talked a lot about this stuff up here, but there's one down here at the bottom that we really haven't spent a tremendous amount of time talking about, which is called mesh paint, okay? Mesh paint used to be the most worthless tool in all of Modo, right? It used to be quite horrible. And the idea behind it is that we would interactively draw, if you will, where a duplicate would appear inside the scene itself, okay? It was so buggy, it made it pretty much useless. It kind of fundamentally didn't work, okay? Well, the developers down at the Foundry finally listened to all of us users, and they rewrote mesh paint from the ground up. And it actually works now with all of these systems inside of Modo, and one of which, let me show you how it works. One of which is Replicators, okay? So the way mesh paint works is it allows us to go in and paint with our cursor where we want duplicate items to be, okay? Now there's a couple things in here that we have to go in and adjust, okay? The source, we don't want some random background layer. We want a very specific mesh, and the cartoon chicken is going to be the specific mesh that we're going to be duplicating inside of the mesh paint system itself, okay? The other thing that we need to change, these are all brush properties, and I'll let you kind of explore some of these on your own. The paint mode up here, yeah, slide works pretty well. There's strokes. I think drop is the one that I normally work with. Let's just do slide. Yeah. So now, there we go. Oops. It's not, there it is. I was left clicking and dragging. I have a little tiny chicken, and see how it just locks it to my scene? That's pretty cool. It locks it to the topology of my mesh, right? So I can just bloop, left click, and it puts one in, okay? And it puts one in. Now what this is doing here, the standard mesh, this is doing component level cloning, okay? If you notice the contents of our item list, it's actually placing all of that chicken information on the plain mesh item itself. I can go in using my component selection tools and grab polygons and continue to work with them. This is component level duplication, which is cool, right? But we can do better. I'm going to go back in time a couple steps. The one that I have used in the past, which I like, is drop. Drop allows you, drop allows you to left click and drag and determine the scale of it, which is kind of nice. And again, it's going to analyze the topology of the mesh and place it in there, which is pretty rad. Okay? But again, component level duplication, which we don't necessarily want. We want replicators, so this renders very quickly. Let's go back in time a couple steps here. I'm going to drop the tool, and this time, I'm not going to do component level mesh paint. If I left click and hold, I want to do mesh paint replicas. Okay? Same idea. It's almost the exact same system, but now what it's going to do is that it's going to, let me just change my source mesh once again to specific item, cartoon chicken. Now what it's going to create for us, and oops, I'm sorry, change my paint mode from slide to drop. Now what it's going to do is it's going to allow me to drop in replicas. And it's going to create the point cloud and everything for me. So if I drop the tool and look at what's been created over in my item list, check it out. So the mesh paint system created the point cloud mesh object, and it also created the replica for me. So this thing is actually not being used. I'll delete it. So it created these two items for me automatically. So now I'm in control as to the placement of all these replicas. I'm still getting the benefit of working with replicas, but now I'm controlling their creation, their placement inside of a three-dimensional scene. And that's pretty neat. If we open up our preview window, yeah, whoops, went a little too close. I apologize. Ta-da! There are all of my chicken skyscrapers just hanging out, which is pretty great. Okay. So we can use both the traditional way of creating geometry and having all of our replicators be created at the verts to create our city, or we can use mesh paint, which allows us to interactively control where our skyscrapers and other details are going to go. Okay. The mesh paint system works very, very well. I think you're really going to dig it. Okay. So I would like you guys to explore how to work and play with replicators by building a small little city. If you explore the mesh preset library, there's a whole series of mesh presets that you can use. Yep, there's a whole category of skyscrapers. Here's the underpinnings of your city. Okay. Yeah, the F6 key will bring open your mesh preset library. And if you look specifically, it's under the meshes section. And then skyscrapers. Okay. Double clicking on one of these, like for example, I'll just double click on that one. Building 68. It's big. It's so big that it's gigantic. Okay, I'll turn off buildings 06, excuse me. I'll return to my scene. Actually, let's do this. Okay. And now, all right. So now, mesh paint replica, building 6. Yeah, now the scale of my building in comparison to the scale of my environment is just off, right? So it's not giving me the result that I'm after, but it should work. Let me get this fixed here real fast. There we go. Okay. I'm just going to scale up my environment so that's of the scale of my skyscrapers. There we go. That'll work. All right. So now, mesh paint replica. My paint mode set to drop. The specific building is going to be number 6, and it crashed. Awesome. Yeah. Thank you, Moto. All right. Questions? Yeah, go ahead.
I'm trying to remember where the mesh library was again.
F6. Okay. Other questions on how to work with replicators? I think once you start working with it, you'll probably start seeing it. Yeah.
I was going through it with you.
Mm-hmm.
Where do you control how many that you drop in the replicator?
Let's go through it one more time. Since Moto decided to crash on me, get my example back. And I think what I'm going to do right off the bat here is that I'm going to put one of those skyscraper meshes into my scene. There we go. This is skyscraper number 1, and it is gigantic. So I want to scale up my plane, which is where I want all of my skyscrapers to appear. There we go. There we go. Okay, that'll work. Well, let's do that. I'll get rid of my buildings. Okay, drop the tool, my sculpting tool, and let's start making the mesh paint replicators. Okay, so I'm in my duplication tools, mesh paint. I'll left click and hold, mesh paint replica. Okay, now down in the tool properties, there's a couple things that we need to change. Personally, I like drop. We can also do arrays and radials. I mean, these are just the cloning tools inside the brush, okay? And then the other thing that I'm going to change is that I don't want my source to be all background meshes. I want a specific item, and I want it to be buildings. Now what I can do is I can left click and drag, and for whatever reason, I want to get out of my polygon selection set. That may have been what was causing the problem. Yeah. For whatever reason, it's not creating, it's not linking this stuff in. Let's investigate. Did it even create the point cloud? No. Why didn't it do that? No, it did. But it didn't wire the point cloud. Yeah, it messed up the prototype. Okay. Let's figure out why this is doing that. That was unexpected, as they say. Okay. So here's my building. It is scaled appropriately. Now let's try it. I had an empty mesh item, and I think that may have been what was causing the problem a second ago. Let's confirm or deny. Drop. Yep. And it crashed. Awesome. So my condition here is not creating the result that I'm after. Maybe it's the mesh presets. It worked well with the rubber chickens. Maybe it's the skyscrapers that it's no liking. Let's see what's going on. Let's try this again. And as a reminder, you don't have to use Mesh Paint Replica. It's just a way of getting to that end result. But now that I've gone down that path, let's see if we can go down it again. All right, try this one more time. Scale this thing up so that it is appropriately building sized. Okay, this time I'm not going to change the geometry and make it all crazy sculpted. Well, let's try it one more time. Because I wonder if this sculpted terrain was what it was getting hung up on. Welcome to computer graphics, by the way. Yeah. This is very, very common. Okay. Yeah, so for whatever reason, and I set it to building 1 is duplicating my plane. There we go. Now it's working. So I changed my paint mode from slide to drop. Okay, then you can just left click and drag. You can drag out a replica, and they can change the rotation of it at the same time, which is pretty cool.
So if that comes out like at a weird angle?
Hold on one second. I'm sorry. I'm having a family emergency. Let's take a break for a couple minutes, okay? Yeah, I did. Okay.
Who did this? Who did this successfully so far? Raise your hand. The replicator just now with the building.
Okay, what do you need to see? Because I can help too.
Because right now.
Because I've got mine to work.
Weird wire frame boxes going at weird.
Okay, let's take it. That's actually a representation that it is in fact working.
How come I can't see the building?
Yeah. Replicators are just going to draw these bounding boxes. So, hit undo a couple stages here. Let's go back in time. Keep going.
It's crashing for everybody.
Okay, well, there's a crash for a reason. We just got to figure out the order of operations which causing the crash. Okay, deselect it. Okay, now where are you going to be drawing your replicators on, or what are you going to be drawing your replicators on? That plane. Okay, do me a favor, subdivide that plane. Do Shift D. I'm sorry. Can you select the polygons on that thing? Now do Shift D. And hit OK. Do like 3 more times. Okay, cool. Drop your selection. Get out of there. Oh,
Does it
now
be an item?
somehow you made an instance of that. Delete the instance. We don't want the instance. Okay?
do that?
I don't know.
didn't even-
I don't know. Okay, so now let's get this all to work. Okay?
Okay.
So go to your mesh paint replica. Yep. Okay, hold on one second. I'm just triple checking your settings. Okay, go ahead and drag one out
And do I put it where I want it?
where you want it. Okay, go ahead and drop. That's fine. Let's see what's going on. Because for whatever reason, it's duplicating the cartoon chicken.
It did that.
It did that for me too. Let's change it to building 5. Now draw out another one. Still doing. Let's do this. Let's do F8. Let's do function.
I was about to. Cartoon.
Hit decline and click back here in Moto. Function F8. Okay. Start the preview render. Let's see what it's actually doing. Okay, so it's zoom out some, please. Okay, that's the prototype, and we are getting duplicates of our
there's
chicken.
chicken.
Okay, so it's duplicating the chicken still. It's not duplicating the background, the building. Let's figure out why. Okay.
Is it supposed to have all of these? And
Yeah, and I think
why are
that just
they-
may be an indication that we've started and stopped this thing a couple times. Get rid of your preview window and drop your tool, please. Okay, and I want you to delete the 2 point clouds and the 2 replicators. Get rid of all of that stuff. Okay, now also get rid of your chicken. Don't need the chicken anymore. Just get rid of the chicken. Okay, so let's try it one more time. Perfect. Okay, go ahead and start it again. And it crashed. That's interesting that's crashing.
Maybe I should just use like a.
It could be, yeah, you used to do the cube, but I'm happy with that. I just want you guys to learn the system. It could be the mesh presets that are causing this to
But it would
fail.
work if it wasn't being weird right
Yeah,
now.
try it with make a rectangle that's the size of a skyscraper, or that looks like a building, and try it there. Yep. Mm-hmm.
So if I wanna, how say that, not subdivide, but create a lot of meshes here inside.
Okay.
Do you have to change the subdivision level or?
No. So with the polygon selected, hit Shift D. Select that polygon. Yeah, that one right there. That's fine. Do Shift D and hit OK. Now it's going to slice that one that one polygon into 4. If you do it again, you can see that it's kind of manually slicing it down here in the bottom, right? Now the location of each one of these verts, we can have a building if we'd like. one other thing, if you guys are having some problems working with Mesh Paint Replica, remember really the solution or the outcome of all of this is a prototype and a point cloud, which is going to drive the replicator network to work. Okay, so let me show you. All we're looking for is just geometry. Okay, just verts. Okay, so if I wanted to have, let me just clean up my scene here. Okay, so if I wanted to have a zillion of these buildings, another way of doing it, this is what I was doing earlier. You can just create a plane, right? And at the moment, my building is gigantic. My plane is way down there. Let's make it bigger. Okay. Now, at the moment, I have 4 verts on this plane. Okay. If I wire in a replicator, if I create a replicator, particles replicator, okay, this is going to be my prototype. This is going to be my point cloud, right? Might help if I selected it. So the prototypes can be the building, the point source is going to be the plane, and now I have buildings at each one of those locations, at each one of the vert locations, okay? If I continue to work on the plane, on what would be the point cloud, I can do Shift D, which is going to subdivide that plane into 4. Now I have more buildings. Shift D again, I have more buildings. Okay. Now there's nothing that says we can't go in and start moving these verts around. Okay. These are just verts. All it's looking for is just geometry. Okay. So I could, I can go in and move these verts around and place them wherever I want to get the solution that I'm after, right? Now they changed it. You used to be able to just hit the backspace key and it would keep all the verts. Now I think you have to go in to the polygon tools and where is it? Oh, it's an edge. I'm sorry. Because now we can remove the edges but keep the verts. There we go. And now we just have verts, right? And I can grab these verts, and I can move them anywhere I want. And see how my buildings go wherever I want? It's just looking for vertex data. That's all it's trying to do. Okay, that's all it's trying to do. So start building a little city using this system.
I'm trying to sign up for next semester.
Okay?
I'm looking for your class, which is for 1.
Mm-hmm.
Can you explain me the difference between 2 of them? So you will have 2 classes in the same day?
This is the lecture, and the other one's the lab.
So the total class will be from 1 p.m. till 4:30 p.m.?
Mm-hmm. Just like the structure we have for this class, right? Because the lecture goes from 9 to 10:50, and then from 11 to 12:30 is the lab.
So I have to select both?
Both of them. Yep. Yep.
It still is not replicating.
Okay, let's figure it out. All right, let's get out of the Mesh Paint Replica because that may be generating the problems here. Okay, delete your point cloud. Okay, now go to the mesh layer at the top of your item list. Let's see what we got. Okay, cool. So this is going to be your point cloud. Okay.
Do I make them on this, in this mesh, or no?
If you go to the replicator, let me show you. Change your point source down here to mesh. Okay, and there's all your cubes.
And that's in
okay.
the replica.
Yeah, which is what it's looking for verts, right? Now this item has a whole bunch of verts on it from that subdivided plane, right? So the replicator is creating a copy of the cube at each one of those verts. There's another way of doing it because all we're trying to generate is verts.
So we don't have to do
We don't have to do that. That's just another way of doing it. If it's causing crashes, we've got to look for a different solution.
And if I want to rearrange them, I just go in and use the
You could,
keyframes,
and there's a
or-
couple of things, other things that you can do in here. If you go back to your mesh layer, okay, I want you to select all those polygons. And go to your edge collection of tools. There's a tool here called remove. It's in the list. It's not with it doesn't have an icon.
Oh, wait, the list.
Keep going right there. That one. and then just do keep verts. Now it deleted all the polygons, but it kept all the verts. Okay, so we can go in and we can select the verts, move them around, do whatever we want.
On each of the,
Yeah, go into vertex selection mode. Okay. Now we have the visibility of our verts turned off, but if you hit the O key, which brings open our viewport properties, the active meshes do show verts right here. Do in component mode. Okay, now we can see the little verts, right?
Okay.
If you select one, move it.
so I can just,
There you go.
oh,
Yeah.
and it controls the building?
It
that's
controls the
attached
building.
to it?
You got it.
And what would, you know me, I do things like the most difficult, time-consuming way. What would be a fast way of just like sporadically rearranging? Is there?
I'm not sure if there's a fast way. If we want to control the placement of all these buildings for like city streets and sidewalks and stuff, you may just have to do it by hand.
Okay.
Yeah, or you could grab a vert and then you just clone that vert.
Okay.
Yeah, that could be a way of getting to the solution pretty fast.
I'm still trying to figure out the whole mesh paint thing, like getting these
Okay, maybe don't use the mesh paint because that seems to be causing some crashes in here. I would probably just use like the example I had before, right, where you just have a piece of geometry, right? In my case, I have a plane, and I built a replicator myself by just adding it. Replicator, okay? Yep. And then the prototype will be the building. The point cloud will be your geometry. Okay, what's next? Yep, so you made it a replicator, right? Okay, now we got to start wiring in all the replicator stuff, right? No, these two right here. Okay. The top two, prototype and point source, is all you need to do.
Clicked on prototype, so
Okay, which one's going to be what prototype is the thing you're duplicating, right?
mesh,
Yep.
just click that. Okay, and point source,
Point source is where,
mesh.
well, what are you duplicating?
Oh, that's right.
Okay, did you double click on a building? Okay, what are you trying to duplicate?
Building.
Okay, in your item list, which item contains the building geometry? So if I look a little closely at your item list here, it doesn't look like you have any geometry for your building in there, right? No? Okay. Now what's in here?
Oh.
Oh, so you did add it in here, okay?
Okay.
You don't want it in there, okay? Now you have to maybe adjust the scale. That building is huge in comparison to the size of that plane, right? So you got to be very mindful of scale. Very, very, very mindful of scale. It's also going to be at the origin of the scene.
If I want to adjust those,
Adjust what?
the sizes of them,
The size of them are, you have to do it at the replicator. You don't really, in this particular situation, you can't do it after the fact. Yeah, the only way to go in and adjust the size is down in our variation properties down here. See, there's random scale. So the point source is where your prototype is going to be duplicated. So the prototype is what is going to be duplicated, and the point source is where. For which channel? Okay, so which point cloud or prototype? Which one are you working on right now? Point source. Okay, so point source is where. So where do you want your skyscraper to be duplicated? On the plane. Which item in your item list has that information on it? The mesh. There you go. Yeah. We'll see. My youngest son was just taken to the emergency room.
You need me to teach class?
Yes, I do on so many levels.
Do a pass this, time to go home.
We'll see. I'm going to apologize right now if I have to stop suddenly.
Ain't nothing like little babies, I know.
Yeah.
I got 6 of them. I know it's probably
Yep.
I'll be praying for you.
Thank you. As you start to work with all the replicators, make sure start adding some detail in there. Okay, if you can, put some buildings in there. And as Melissa and I were experimenting with earlier, those mesh presets may be causing the mesh paint replica system to crash. You don't have to use the mesh presets. You can just use cubes, gigantic cubes to represent the buildings. We're just trying to create an understanding that of the system itself. The details we can always continue to refine later. But light posts too. Put cars on the street. There's actually some great presets for cars. You can figure this out. It's not too bad. And then when you're done, I want you to animate a camera traveling through the model and then render it out. Okay? See all your hard work kind of come through. It's always nice to see that. And you can change, if you're using just a plane, you can change the location of all these verts to start crafting, city blocks and what have you. It goes pretty fast, okay? And since you're just working with verts, if you can also just duplicate at the component level these verts. I'm just going to use the clone tool. There we go. I forgot to select one. Let's try it again. There we go. Now I'm cloning just the vert. So you can make straight lines pretty quickly, up and running. This is the cool thing about working with the Modo toolset is that it's just verts, which is nice. So however you want to duplicate the copy, paste, that's not working for copy paste, but you can start cloning them and start making it work too. It's whatever works for you, right? You can use the mesh paint replica system, or you can create just actual geometry and move the verts around on the geometry. All we're trying to get to are just verts in the scene that the replicator gets linked to. And then wherever a vert is, your building is going to be placed.
But if I will create cars, do I have to manual or as well using Replicator?
Yeah, so it'd be another replicator that's just doing the car.
And another mesh.
Another point cloud. Yeah, another point cloud to determine where the placement of those cars are going to go. Yeah, so at the end of the day, you'll probably have 3 different replicators and 3 different point clouds. Replicator for the buildings, the cars, and the light posts, and a point cloud for each one of those as well. It's under the particle list, or the add item particles section. Yep. So if you want to change the size of the buildings, there's a couple ways you can do this. In the variation section down here, we have scale. So you can randomize the scale of all these buildings. Okay. Yeah.
Okay.
That's cool.
Okay, but still I need to make it smaller.
Hmm. Now, is that a deal breaker that it's so big?
some overlap. No, looks like.
Yeah. I say keep going, in all honesty. Keep going. See what you can get. Yeah.
Prototype, every time I use the mesh paint, it just sort of duplicates it.
Ah, okay, so you're in Mesh Paint. You want to be, drop your tool, get out of here. Left click and hold. You want to be in Mesh Paint Replica.
Oh, okay.
Okay, now let's see, now let's look at the properties down here and let's see specifically what's going on. So it's all background meshes for the source. What if you do change that to specific mesh? Yep, and then what do you want? Is mesh the cube?
Yeah.
Yeah, okay. Try it now. Let's see what we get. Now, is it doing it? Let's see.
It just,
The point source is being set to plane, and the prototype is being set to mesh. So it's not honoring what we wanted to do. What if we change the prototype? Oh, no, that's right, because mesh is the cube?
yeah.
Yeah, okay. Now, I'm thinking zoom out just a little bit. Let's see a couple things here. In addition, if you zoom in, drop your tool real fast. That's weird. Looks like there's a couple copies of that cube sitting right on top of each other. Okay, so one of them, turn off the replicator, because I want to see the difference between the replicator and can you turn on mesh? Where is mesh?
It just disappeared.
Okay. Oh, there it is. Okay. Before we go any further, I want you to grab the polygons. Okay. Double click on your cube, and I want you to center it. Basic section. Do center selected all. Okay. Let's try that. Okay. Let's try it one more time.
Okay.
Let's see what we get. Okay. Yeah. Let's delete that replicator. Let's get rid of it, and let's also get rid. Hit the A key. Okay. So let's try it again. Let's see if we can get it to work. There we go. Now before we click, let's change some of our properties, or at the very least double check properties. Yep. Okay. No, we don't have to. It's going to create it for us.
Oh.
Yeah. That may have been part of your problem. Yeah. So it created a point cloud in the replicator. Drop your tool for me real fast, and let's go over to the render. Let's see what we get. I'm curious if it's actually there or not. No, it's not there. Okay. Whoa. Check it out. It nuked it. Okay, let's go back into the model tab. This is strange. What? Okay, let's try it again. Okay, so got the point cloud, got the replicator. Now, what is different about yours? Okay. Let's look at the properties down here. I have no idea. This is weird. Okay. Let's not worry too much about it. We can do this with other systems. I'm not sure why this is breaking the way it is. Let me do some investigation. Yeah. Start making your city with traditional, planes and stuff, and we'll go from there. Okay. All right, so the second part of our lab this week, or the second part of this class this week, is to begin to explore rigid body dynamics. And as I mentioned at the beginning of the class, what we're going to be doing today is, kind of creating a simple domino run, a domino rally, with all the domino bricks falling over. And in doing so, it'll give us a great opportunity to explore how the dynamic system can simulate these interactions between all these dominoes automatically for us. I think once you start playing around with it and exploring how all these parts and pieces are working together to create the simulation, I think you're going to find that it's pretty cool. The results are going to be pretty neat. It does create a little bit of labor, if you will, in order to get all this stuff working, but I think it's one that is worth the time and energy and effort. Okay, so let's jump back over here into Modo and see what we got going on. It's pretty easy to get this stuff up and running. Okay, so I've created a simple little red domino, and I'm going to have, or I want the computer to automatically simulate this guy, boof, just falling over for us. Okay, so we're going to start to tag each one of these items with a specific rigid body simulation tag. Okay, it's important to point out before we go any further that the entire simulation engine inside of Modo revolves around items. Okay, this is an item-based simulation system. Okay, replicas, not going to work. Okay, instances absolutely will work. Okay, so I'm going to have a whole series of instances of my little red domino here that I'm going to have the computer automatically knock over for us. Okay, so there's a couple of things that we need to set up and establish before we can hit the play button and watch the computer kind of go to work for us. The first thing that we need to do is that we need to set up these item tags and tell the computer which type of rigid body that this participant's going to be. Okay, so let's check it out. It's really easy to do this. I'm in the setup layout. You're only ever going to find all these options inside the setup layout. Okay, don't worry, we're not going to do any rigging today, so don't freak out. But let me, go into item mode here real fast. I want to select my domino. Okay, now where we're going is the dynamics section towards the bottom of our toolbar, and specifically up here at the top. Okay, all of these guys, because there's a couple different types of rigid bodies, or a couple different types of rigid body tags that we can apply to the characters inside of our scene. Now, the distinction between them is really important, okay? Because there's really kind of three that we need to keep in mind, okay? We have an active rigid body, kinematic rigid body, and static rigid body. Now, there is a difference between the three, and let's kind of define what those differences are, okay? An active rigid body is going to allow the physics engine to dynamically control the movement, rotation, and speed of movement of whatever object it's tagged to. Okay, so think of it like this: an active rigid body is something that we want to move. Okay, the domino we want to move. We want the physics engine to push over the domino and all of its friends. Right, so those are going to be moving assets or moving items inside the simulation. So those are active rigid bodies. Okay, now a kinematic rigid body isn't something that's going to move based on physics. Okay. But it's still going to be a member and participate in the simulation. Think of this like a platform. Maybe we want the platform just to kind of animate back and forth like this. Okay, so we control its movement through keyframes, not through the simulations, but it still can detect collision and have things bounce off of it. I'll show you that here in a minute. Okay, and then lastly, we have a static rigid body, which we aren't going to animate. We don't want it to move, but we do want it to generate collision information for the sim itself. So the ground of our environment is a perfect candidate for a static rigid body. We just want it to sit there. We don't want it to fall. We don't want to have gravity influence its location inside the scene. However, we want the dominoes to poof, fall on top of it. Okay? So we do this through a whole series of tags. I got my domino selected, and I'm going to tag this shape as an active rigid body. Before I do this, and I forgot to mention this earlier before, okay? Earlier before? That's not good English. I forgot to mention this before. The location of our center points is really important. If you notice where my center point is, where is it? Yeah, it's at the bottom of the domino, okay? This may be something that you're going to have to experiment with. I want the domino to fall over like a hinge, okay? So I've put the center point down there. Now, the center point is where the computer is going to calculate the mass of this object. I'm going to experiment and see what I get. But if I'm not getting the simulation that I want, changing the location of the center point to the middle of the domino is going to give me a different result. The computer is going to calculate the mass at the location of the center point. So in every sense, we're telling the computer that the bottom of our domino is going to be the heaviest. That's where the center of mass is going to be. So we may want to look at that and see if it's giving us the illusion that we're after. The cool thing about working with simulated geometry and simulated movements is that we can tweak these parameters to get the result that we're after. Okay? The computer is going to do all the heavy lifting for us, but we need to go in and initially set some conditions to get the first round of it. Okay, the first go. All right. So with my domino selected, I'm just going to hit the active rigid body tag, and on the surface, nothing seems to have happened. However, if we go over into our properties panel, we now have a new tag down here at the bottom called Dynamics. And this determines all of its dynamic properties, including which shape it is, how bouncy, how the friction level. I always think, in my imagination, this is kind of like a sandpaper quality. If the friction is at 100%, it's like sandpaper. If it's at 0%, it's like glass. It's really smooth. Okay, that's going to determine how these things fall and rotate and bounce, or in with all the other stuff inside the scene. Point being, we're going to have to go in and adjust these values to get the result that we're after. Okay, we'll talk about some of these other properties here in a second. So I got my domino tagged as an active rigid body. I've selected the mesh item here in the background, which is just a single plane. From my explanation a second ago, which of these three tags do we want to do for the plane? Static, right? Because we want it to be a member of the simulation, but we don't want it to move, right? Let's go ahead and apply the tag to my mesh. And we're ready to start working here. Well, we're almost ready to start working here. Let's do this. I'm going to grab my domino, and I'm simply just going to move it up away from the plane, which is right there. Okay. Now, in doing so, will allow me to basically drop my little domino brick on the ground. Okay. Let's do it a little higher. Now, to start the simulation, there's a couple new buttons that we need to press, and you can find them downstairs in our timeline. Go away, Doc. And this is these three buttons. Okay. Each one of them has a very different role. The first one is just going to run the simulation, okay? And it's going to run it infinitely. It's never going to stop. The second one is going to run the simulation, but only according to the time frame settings of your timeline. So it's only going to run from 0 to 120 frames. And then the last one actually computes and saves all the simulation data on your timeline. More on that in a minute. Let's just run the sim and see what we get. Awesome. Cool, huh? Let's stop it and try it again. Cool. Let's stop the sim and make some changes. What if I rotate this down a little bit, like this? Let's run it now. Kind of fun, right? This is where the parameters need to be changed. And I think at this point, I'm ready to make the decision that having the center point down at the bottom is actually giving me a really weird, wacky result. That's not exactly at all what I want, okay? Right? It's like one of those little clowns with the sand at the bottom. You punch the rubber clown, and it just kind of slowly sways back and forth. While this is cool, it's not at all what I want. Okay? So we need to make some changes to the actual make some changes to the center point here real fast. Okay? Let me stop the sim. And I'm going to just make my life a little bit easier and reset my transformations back down to 0. Of course, I don't want that 40-degree rotation, which allows me to very quickly adjust the center point. Let me turn the grid on so I can see what's up. Because I think really what I want to do, there we go. I don't need to change the location of the center point. I need to change the location of the polygons in reference to the center point, right? If I just center my polygons at the origin of the scene, I think I'll be good. So I've changed my selection set to polygons, and simply returning to the basic tools and firing off center selected all will give me what I'm after. Let's see how that one small, simple change changes the sim. I'm going to turn my grid off again. Let's move it up, rotate it forward, and play the sim. There we go. That's a little bit better. Right now we're getting a little bit more of a realistic simulation. So the location of the center point is crucial. Keep an eye on it, okay? I haven't done anything here that is super magical. We've done this often with the rigging stuff that we talked about earlier in class, right? Let's explore how some of our dynamic properties can change the simulation. Because right now, if I just run the sim, yeah, maybe I want it to be a little bit more bouncy. Let's go over to my dynamic section, and let's increase the bounciness. Okay, let's put it at, I don't know, 60%. And run the sim again. Yep, a little bit more bouncy. Let's put it at 100%. Yep, slightly different result. Now the bounciness and the illusion that we're creating here is really a composite of all the participants of the simulation. If I really wanted to have this cube kind of bounce on the surface, maybe the solution is not changing the, someone's playing music outside my window, which is incredibly distracting. Maybe the solution isn't increasing the bounciness of the cube, but increasing the bounciness of the ground. Okay, kind of make it into a rubber mat, if you will, and then our object will bounce across the scene. Let's do that real fast. And just for clarity, I want to change the name of mesh to ground. There we go. And let's change its bounciness. Let's change it to 60. I usually make small kind of movements in here. That way I can kind of dial in the simulation. Yeah, look at my cube now. So I didn't change its properties. I changed the ground's properties, and I'm getting a much different effect. Okay. Boop. That's pretty cool. Yeah. So I'm going to leave the conditions of my simulation as is, but return to my domino, because I want to talk about mass. Because I like the bounciness of it, but I want this to feel a whole lot heavier. And I mean a whole lot heavier, right? It feels very light and wispy, and the movements of the domino really kind of isn't where I want to be. So one of the properties that we have here is mass, okay? And what I like to change, we have local density as the input value for our mass. What I like to change is from density to actual weight. It's a little bit easier for my brain to figure out. So if we do local mass, okay, now we can define kind of a weight of the domino, right? Maybe I want my domino to be 10 lbs's, 10 pounds. Let's see how that small, simple change, okay, a little different. Let's make this, let's just add a 0. See how that changes it. Not a whole lot. It does look like it's dancing. Still doing the exact same thing. The gentleman outside singing with the guitar is really distracting. Should I give him the old man go away look? Yeah, he's literally right there. That's funny. Anyways, okay, all right. So I think to get what I want, I'm going to have to go back to my ground and maybe just dial down the bounciness a little bit. Too much information is being passed between them. There we go. That's a little bit more realistic. The larger point that I want you to see here is that you're going to have to tweak these settings. There's a lot of increase that, decrease this. You know, we're trying to make a recipe here of different properties, different dynamic properties to give us the result that we're after. Okay, the two that I focus in on the most are bounciness and friction. Now, if we increase the friction, it's going to act like glue. These surfaces aren't going to slide around the surface all that much. Okay, let's do this. On my ground, I want to put my friction to 0%, and let's see how that changes things. See how it's sliding there now? It's like it's ice. Okay. The friction property increases, in my mind, it's like sandpaper, right? The higher the percentage, the more like sandpaper it's going to be. Let's do the inverse of this. Let's go 100%. Poof. Say again? Yeah, absolutely, and that's going to change the simulation, change how it's going to move. So these are all factors and variables that are combined together to give us that end result. So with the friction at 100%, we're getting a pretty cool, and then it just sticks there, right? Let's put this down, back down to 30. So it's going to move around a little bit, but eventually it's going to stop. That's pretty cool. Okay. All right, I'm going to go back to my domino here for a second and return to its item properties. Let's put this back to 0. Its rotation back to 0. And now for this next bit, what I'm going to do is just raise the domino up ever so slightly above the ground. Let's play the sim. And you see it just kind of stops for a second. Yep, there we go. Okay, I'm happy with that. So it just falls to the ground, kind of jitters around a little bit, exactly what we'd expect to see. Now we can continue to control our dynamic objects, back to the Dynamics tab, with this impulse section. Okay, this is pretty cool, because what if I wanted to have something push my domino over a little bit? Okay, because right now gravity is just bringing it down to the ground, but what if I wanted to push it forward, as if to push it into the domino that's next to us, right? A force of some kind. Yeah, that's where this impulse section comes in a little bit. It's not force. A lot of people think that you go into the force section to push it. This actually starts to change how the forces are being interpreted by this object. The impulse section actually allows us to push it a little bit. Okay, so impulse, think of this as the push. Okay, notice that the unit of measurement here is newtons. Okay, so whenever you see N, that means it's a force. It's a physical kind of push. Now, the impulse is how much or how hard we're going to push this object. The impulse position is where we're going to push this object. And the torque is going to be rotation. So if we wanted to spin it a little bit too. Okay, let's simply push this little cube over here. See, I wanted to push it. I'm looking at the center point. I want to push it along its z-axis positively. Okay. So impulse z, let's just put this to 1 newton, see what we get. So now we're pushing it forward. Not enough. It did move ever so slightly. Let's put this to 5. Yep, I saw it move. Let's really crank it. Let's put it to 15. Yep. It's doing it. Sometimes you just got to figure out the value. Yep. And now, poof, there it goes. Let's put it to 60. Let's double it. There it goes. Let's put it to 200. Yeah, now we're getting somewhere. So it's all scene specific and scale specific. Okay. And it has a lot to do with the weight too. Yeah, my thing is 400 kilograms. That's pretty heavy, right? 4 kilograms. So that's a really good point. If we were to bring the mass down to like 50 pounds. There it goes, right? For a domino, I love it. I love it. So you can get pretty accurate if you like, you know. So all these things have a factor in it. That's fantastic. I kind of liked it being a little bit heavier myself. So I'm going to hit the undo key. Yeah, that's a little bit more of what I want. So increasing these, let's do 400 newtons. There we go. All right, so now I don't like where it's being pushed. If you look carefully here, it's being pushed at the location of its center point. What if I just wanted to push down from the top? Okay, that's where we can start adjusting this impulse position. Now I got to figure out where that location is inside of our three-dimensional scene. So a little bit of investigation is required. I'm going to look at my scene from the front here, and I'm going to grab. Let's see. I want to figure out that location of that vert inside of my scene. Okay. So here's a great little trick. I'm not going to be able to do both at the same time. But down here, it's going to tell you where your cursor is. Okay? So watch down there. I'm in the lower left-hand corner of my application. Oops. So what does it say? It is 33 inches up on the y-axis. So that's a good ballpark of where I want to be. All right. So now that I know the location, I'm going to return to my dynamic properties. And I want to change the, oops. Let's make this a little bit easier to see. Change the impulse position to 33 inches on the Y. Now it should be pushing it right about there. Yep. See how it just looks like it's being pushed over from the top now instead of in the center? So we have a lot of control over how all this works. The impulse is how much we're pushing it. The position is where we're pushing it. And then last but not least, this is the torque. I'm going to get rid of my impulse, and let's just spin this thing 200 newtons along the y-axis. That's cool. Okay. Let's get another player in here. Okay. Let's get another domino and see if we can create a very simple chain animation. Now the cool thing about working with these dynamic tags is that they're going to follow the item whenever we change and duplicate that item. So I have my basic dynamic properties set up for my domino. However, I am going to go in and remove the torque. There we go. And now when I'm holding down Control Shift now, duplicate it, all those dynamic properties and those dynamic tags are also being duplicated. Okay? Let's test it. Yep, they all move. Cool. On the first one, let's give it a little bit of a push. What do we have? We had 200, or on the Z, excuse me, 200 newtons. Oops. Now, why did all four of them fall over? They all had a push. Well, they're all instances of the original, right? So let's do this. Let's go back in time. Let's get rid of, oops, I'm still running my sim. That's dangerous. Okay. One thing that a lot of folks forget is that when the move tool is on, see how the duplicate mode is set to instance? We just want to do a straight up item level duplication. That way I can make changes to the first one and not have to worry about just duplicate it. You got it. And then I'm just going to return to the first one and give it a little bit of a push. This is a fun one. Let's see if it works. There they go. Yeah, I mean, you're free to do whatever you'd like to do. They're pretty intricate, aren't they? Yeah, they're pretty cool. Yeah, and have fun with it. I'm just going to lower all these down so they don't fall as much. What you don't want is your dynamic shapes going underneath the ground plane. So watch what happens. This is fun, actually. Yeah. They pop up, and in certain situations I've seen them like really jump up and then come back down. So you want to try to keep them above the ground as much as you can. I try to get pretty close. There we go. Let's play it now, see what we get. Poof, on our way. Okay? Pretty cool, huh? Pretty cool. So your homework this week is to make a domino rally, a domino run, okay? Please be creative. Do whatever you'd like to do on this. It doesn't make really a big difference to me. It's going to be a 10-second animation, so you're going to need to have some sort of intricate shape in here to get you what you're after. Use the duplication tools, and especially use your creativity to produce something that's pretty fun and pretty magical. If you were to go back into Canvas, yes, all this was live streamed, 100%. Okay. Under the Domino Rally homework assignment, 10 seconds. Okay, at 1920 by 1080. Okay, so slightly larger resolution. The setup for your animation is going to go pretty fast, but make sure you're giving yourself some good time to render it this week. This could, if you put some energy into this could be a really great little portfolio piece, okay? And it's just a lot of fun, okay? Shoot, you could actually make a domino rally like this individual does if you have the patience to do it, which is pretty cool. The more complex and the more intricate the design is, the cooler the result's going to be. So have fun, be creative, okay? It should be a pretty engaging animation, and it doesn't require a tremendous amount of setup. Now, one thing I can see on his screen over there, I want to show you something. This is actually kind of important, okay? Well, it's not critical, but it's going to save you a lot of energy. So the spacing of each one of these is kind of important, okay? Because you don't want to have them so close together that they're going to get all jammed up, right? So you don't want to do this, and this is not, you don't want to do this, right? Where they're just right on top of each other. That's going to cause some problems, okay? Awesome problems, but problems nonetheless. Let me get rid of that push. Okay, so you want to kind of space them out a little bit. One of the things that I've seen people do is create a simple little measuring stick, because you want the spacing in between the dominoes to be slightly smaller than the height of each one of your dominoes, right? Does that make sense? Yeah? Okay. Let me show you what I'm talking about. So here's the height of the domino, okay? So if that's my measuring stick, that gives me a really good indication as to where this one needs to be, somewhere right around in there. And you may even want to make an actual measuring stick to help you figure out the spacing, because you don't want to have so many dominoes that the solution or the illusion doesn't work, okay? So this is my measuring stick. I'm just going to, excuse me, looking at it from the wrong perspective. There we go. Let's delete that one. Put the push back on our friend here. Let's play the sim, see what we get. There we go. Okay. If they're really jammed in there, you saw the result earlier. They kind of bounce on top of each other, and it doesn't look realistic. And you're going to have a zillion of them, too, right? We don't want to have a zillion of these things, okay? We want to have a good amount to create a fun kind of animation, but not a zillion of them, okay? I think that's going to help. Another thing that's also going to help for the render of this, and this is going to add some time. Let's play the sim. Just want to see where we are. Yeah, okay, great. So there's a couple things when you're ready to render. First and foremost, you need to compute the sim down here at the bottom. These two are just going to play back. Temporary, okay? The playback is only going to be available to the current session of Modo. So if you were to quit Modo and reopen this project file, all your dynamic stuff is going to be gone, right? So we actually want to compute the sim, which is going to save all this sim data into your Luxology project file. If you have a bunch of these, your Luxology project file is going to get big, okay? Because it's a lot of data that it now has to manage. So let's compute the sim. For me, it only took a blink of an eye. You didn't even see the little progress bar. On more complex simulations, you'll actually get a little status bar that shows you the computer crunching the numbers. And then once we compute the sim, that information is now saved to this project file. And now, to play the sim, we play our timeline. So once you compute the sim, buttons number 1 and button number 2 we don't want to touch, okay? Now everything's been kind of saved to our sequence, saved to our timeline. So you definitely want to make sure you compute the sim before you render, okay? In addition, one other render thing, and I'm going to find a frame here, frame 29. Let's go look at frame 29 inside my camera. One of the things in here that I think you guys are just really going to dig there we go. It's motion blur. To really make this look cool, to make it look photographic, motion blur is an excellent thing to add into, especially for an animation like this. Takes a little bit longer to render, but I think the results are worth it, in my opinion. If you notice, on this particular frame, my members of my sim are moving, but we're not seeing any inherent motion blur on the objects up here. This entire domino should be blurred out as it's starting to tip over, because it's in movement. It's actually moving pretty fast, okay? Motion blur is a great thing to add. I really recommend it. It's a camera effect. So I've selected my render camera, camera effects, and then motion blur right down there, enable. Leave the default settings as is, okay? Looks great, doesn't it? You shouldn't shake your head because nothing's changed. Sorry, that was a trick question. No, yeah. Melissa was like, yeah, that looks awesome. Still looks good. This is the part that usually kind of freaks people out a little bit because they go, where's my motion blur? Okay? It's final render, but we can preview it, okay? It's off by default because this takes a lot of processing power to preview the motion blur. It's one of the options of your preview render. And I'm zoomed in so close I can't even see it. Motion blur, right there. There it goes. And now it's blurring that object. Yeah, cool, huh? Let's find a frame. There may be a frame when they're both in motion. Yeah, because this one's getting blurred out a little bit, and this one's getting blurred out a little bit. The motion blur is what creates this cinematic look, this photographic look for all of our movements, okay? It's a simple thing to add, and it's going to add a tremendous amount of realism to the animations that you create, okay? It takes a little bit longer to render, though. A little bit longer, okay?
It will be automatically blur their items on the...
You got it. The ones that are moving are going to automatically get blurred. Yeah, it's pretty cool. Let's just do a quick little render. See how long it takes.
Some cameras as well, or no? Do we have to use some cameras? Several cameras.
You could if you wanted to. Yeah, you don't have to. You can animate the camera to track your movement or something. That'd be fun. All right, so there it is with it on. Took 15 seconds. Let's turn the motion blur off. Render again. It's probably going to be faster than 15 seconds. Yeah.
Is there any rendering software that can make it go faster? Like instead of rendering it in Moto where you could take your project and put it somewhere else?
Yeah, because rendering motion blur is slow. In every app, it's slow. It's usually it is not just a Moto thing. You render in RenderMin, you render in V-Ray, Arnold. Motion blur is going to take forever to render out. It really slows things down. So what a lot of folks do is they use a plugin for Nuke or After Effects. It's called Real Smart Motion Blur, and it looks at the movement of all the pixels within the frame, and it starts to blur those pixels based on how much they're changing or how far that pixel has moved in between the frames. And it goes a whole lot faster. But the plugin is something you have to buy, and I think it costs like $150 or something like that. So you got to figure out how much your time is worth. So the other solution to the problem would simply just be get a faster computer or render on more computers. So there are ways of making this a little bit more efficient. It's something that all artists struggle with. Yeah. Yep. So check it out. It's really good stuff. It's going to make your animations feel a little bit more believable. And for something like this, where we don't have a lot of complex geometry, whose weight is very polygonally intense, it's going to go, I think, pretty fast. If you look at these render stats here, let's see, elapsed time is 15.4 seconds without motion blur, and then 15.9 seconds. So you're not even, that's a marginal increase. That's something that I wouldn't even really, huh? Yeah, you saved a really long blink of an eye with adding motion blur on this. So please do it. I think it's going to be pretty neat. The other thing that you'll probably want to add on this animation to give it a little bit more visual fidelity is different materials. I have one material that's shading all of my polygons red. But if you look at some of the examples that I provided to you on Canvas, man, what makes these things come to life are different color dominoes at different places. And now it turns into this wonderful, almost like kinetic art. So I really encourage you to look at that and see how you can make a really beautiful animation with literally simple building blocks. Okay? Make sense? 1080p though, 1920 by 1080. Okay, I want you guys to feel what it's like to render something big. Okay. Does anyone remember where to go in and change the render properties, the frame settings? Yeah, it's in the render item. You got it. So if we go back over here into Modo, let's just look at the render item one more time. Boop. Okay. And then it's under frame. So 1920, oops, 20 by 1080. Okay, this is 1080p. This is the highest flavor of HD quality that we can render out of Modo. Okay. I don't want you guys to render at 4K yet. I don't think we're ready for that. I've rendered some stuff at 4K, and man, it's like you hit the render button. It's like, okay, I'll see you in a week, right? It takes a long, long time to render things at 4K. So we'll render at 1080p. Out of curiosity, let's render this frame one more time at 1080p and see how much longer it takes. 1080p is kind of addictive because once you start creating more pixels, okay, you're going to notice a drastic increase in the quality of your work. But you know, that comes at a price, unfortunately, of just render times. I refuse to draw anything at 1280p anymore. Everything's at 1080. Then every once in a while I'll render something at 4K and I go, ooh, look at my pixels. It's so pretty. Yeah. All right, it took so twice as long as one might expect it. The resolution, doubled in size, so the render times doubled in size. So prepare for a long render. If you're concerned about your render, one thing that I think is an excellent reminder, okay, the Design Lab will hold a computer for you. They really will. You can go in the mornings, set your computer up, or set one of the Design Lab computers up to render, and then you can sit and let the computer render all day. They'll lock down that machine. They'll put a sign in front of it, and they'll say, huh? Yeah, they have a little sign, and they'll lock down the machine. Right, you got it. So, and then you just come and pick up your frames at the end of the day or whenever it's done. I think overnight renders are doable in the Design Lab, but we have to really incorporate the Design Lab staff, okay? But all day renders, and if you show up when the Design Lab opens at 8, and they close at 9, I mean, that's 13 hours of render time that you, in theory, could employ. That's a good chunk. This is not going to take 13 hours to render, by the way. It is not going to take 13 hours to render, all right? But know that that resource is available to you guys, okay? And use that resource. You can also jump onto a couple different machines, too. If it's the 11th hour and you're trying to turn this thing in, break the render up across a couple different machines. You'll increase your render time by a magnitude. Make sense? Pretty much, yeah, pretty much. We'll talk more about advanced level rendering as we get closer to the final project in here. Modo actually has a really great network renderer built into the app. I have yet to do it in this room, but on this installation of Modo. But in my old room, I used to do it all the time. I'd take control of all 26 of the machines, hit the render button, and wow, it's cool. It's cool to see 100 different buckets show up in your render. Yeah, it's awesome. It's pretty cool. All right, so we got about 20 minutes left in class. Let's get to work. Let's finish up your lab and start your homework if you haven't already. Okay. Yep. Hold on 1 second. Okay. All right. Wait, nope. Huh? Okay. Okay.